which apparently works really, really well. I've never done it personally, but because I'm not a big Struts fan. But it just kind of shows the flexibility of what the ESAPI offers. It's not a one-size-fits-all solution. It's something that needs to be adapted to your business. I can't stress that point enough. Output escaping, canonicalization, encryption, random numbers, exception handling, logging, intrusion detection, security configuration, and a web application firewall, which I believe we're changing with the next version of ESAPI. The next reference implementation we'll use some great work from another OWASP project called AppSecUSA. Or that'll be for intrusion detection. So this is where I was going to do a really cool coding demo, as you can see. Unfortunately, we're not going to be able to do that. So what I kind of like to do is I'd like to make it a little more interactive. And I'd like to ask you guys to volunteer a little bit of information and give me an example of something that maybe as a developer you've had to solve, or maybe as a security professional, maybe there's something you've seen where it's like, this is a really complex problem to solve, and we'll actually walk through and say, okay, how could we solve that problem with the ESAPI, or with an ESAPI? So I'd like to kind of open it up to you guys. If anybody has any examples, start with you.
Yeah, I'm not a developer. I'm an InfoSec person, network engineering, but in a PCI environment, one of the challenges we have is how do we control the encryption keys in an environment that meets the PCI DSS requirements? You've got an encryption key to encrypt the credit card numbers, basically, and then you have another key to handle that one. Like, how do we get into .NET type of environment?
Okay. So encryption is one of those, and this is something that's come up several times did everybody hear the question? So .NET environment, managing in a PCI DSS compliant application, trying to manage keys. So basically it's key management. This is something that's come up on the mailing list several times, and it always kind of ends up in a chicken and egg type problem, right? Where here I need some way to manage my keys, but I need a key to lock down where my keys are managed, so who manages the master key? Really, I don't think anybody's come up with a 100% great solution to that problem. And Jim's got something to add here, so I'll let him fill in just a second. But I think that ultimately you're still going to have to rely on manual process there. You still need some type of manual. You need a guy who manages your keys, or manages at bare minimum the master key. We've kind of solved the problem by making that part of the security configuration for the application. So if you can manage your security configuration and keep that secure, it's a file system. So you're relying on file system security. Now that's not the only way to do it. That's how we've solved the problem, where basically we plug right into the security configuration. This is the master key. And I think there's lots of ways to solve the problem, but at the end of the day, you're still relying on some human or a group of humans to manage that aspect of your application security program. Jim, what did you have to add?
Just a couple more specific use cases. First of all, I highly recommend you look at the XSS cryptographic cheat sheet. It talks about all the elements of key management and the key lifecycle. It's one of the most difficult issues in security engineering, period. So there's two big use cases. One, you have to do batch processing of millions of credit cards every night. You need to decrypt them yourself as the company. Then you're screwed. You pretty much have to have a master key. If that master key is compromised, you're done. And you have to use the other controls to lock that down. There's no way around that. Now, if you don't have that use case and you just need to save the credit card for recurring payments, then encrypt the credit card, not in a batch, but per user. So every user has their own key that can be generated even based on the user's password in some way. So now you have only the user themselves at the time of login has the ability to do credit card decryption. Much more secure when you don't need the master key anymore. It's per user credit card decryption, which again, you can't do that if you need to do batch processing at night. In that case, you need a master key. Those are two of the big use cases. And even better, Don't store credit cards. Push them off to a verifier and sue.
Drew that. There's the real solution. Make it somebody else's problem.
Yeah. Business use case.
I totally agree with you.
And Jim, what about the use of an HSM then? To an HSM, a host security module, to securely generate store key or hardware security module? Yeah.
It's not my primary area of expertise. It's another powerful tool for key management. And especially if your HSM provider is big and you can sue them when they screw up, all the better. Seriously, if you're depending on a vendor solution to protect credit cards by the millions, they better be big enough so you can sue the heck out of them when things go wrong. If they're too small and they screw up, you take that liability. You're done. Make sure they're big enough to sue.
And what's interesting about the vendors of the HSMs is they sell the same device, NIST certified and not certified, at two different price points. Same exact device, just you're paying for the certification on the NIST certified one.
It's nuts. Actually, when I talk to HSM providers, I want intensive assurance evidence from them. Give me assurance evidence of your code reviews and assessment, and so I know that you have a secure solution. Most of them go, huh? So I would, as a vendor, as a purchaser with big bucks, I would try to force assurance evidence down their throat to return to you before I make a purchase. Otherwise, sue yourself.
Great point. Thanks.
Go ahead.
So I'm an app that, back to the slide you had earlier with the little padlocks were spread all throughout the app, right? And then
that one.
So like authentication is kind of embedded in each page as opposed to being centralized. The same thing with access control.
Okay.
So how do I make that more manageable with the ESAPI?
All right, so let's see. So you've actually got, so in your UI layer then, you've got like tags? Do you have tags doing access control checks?
Scriptlets like Java,
or scriptlets?
stuff like that. So it's going to be one-off, one developer did it this way, another developer did it that way, but there's a central database, JDBC access on the back end that has all the usernames and roles and whatnot.
So at work, I've actually got a nickname. They call me the dynamic proxy. I'm not sure if you know a whole lot about object-oriented development. A dynamic proxy is basically code that gets proxied in place and gets executed maybe before something happens or after something happens, or something that can redefine the code execution pattern. That would be ultimately my solution. Probably the big would be okay, so step one, you need to move you need to build an adapter, basically, for ESAPI and plug your adapter in. So you would build an implementation that would be my JDBC authenticator, my JDBC access control. Those then get access through the ESAPI service locator, which is literally just a class with a bunch of static methods in it. It's kind of a factory class. So you would call, where you would normally call going forward, where you would normally call, you'd have a tag that says, can access, right? You would replace that with a call to ESAPI access controller. I forget the method. Basically, there's a series of methods on the access controller that say, do I have access to this type of thing in this context? So then what you can do is you can take, once you've got that portion built, then you're going to want to take all the code that's being called currently, right? So I'm assuming on the UI layer in the script, you probably got some data bean or DAO that's being called, or maybe a facade layer in between the actual database call to do the access control check and where it's actually being called. So that's where you want to say, okay, so I'm going to change this from going to this DAO method. It's now going to go over here to the ESAPI locator, get the access controller, and run the access control check. At the end of the day, it's still going to your database, right? The biggie that you're getting here is, in 2 years' time, somebody comes out with some brand spanking new hot access control and authentication library. And your boss comes to you and says, hey, we want to use framework A to do our access control and authentication. In today's world, in applications like that, I've got a lot of code to change to make that happen. This adds that layer of abstraction where I can literally swap out security controls for the latest and greatest without touching all of my code. In addition to the fact that it allows the developers to not have to think about the security controls. I know that when I need to make an access control check, I call this method. What happens behind that method, I don't care about. You either got access or you don't.
So, like one of the problems is, say, with multiple login pages, password expiration is enforced on one but not on another, that kind of thing. So using this centralized security with this, would like a servlet filter or something like that work well too? And
a filter would actually work really, really great for that. You could actually, and the great thing about filters, my boss hates filters. I love them. I love being able to catch something midstream and say, you know what, you want to go here? And then, no, you're not going. Right? So you could actually catch it at that point in time, and you could say, here's these 2 login pages. This one's not a valid login page. Right? I want to catch anything going to this login page that does not enforce password expiration, and I want to take anything going there and redirect it over to this one that does it correctly. So that would absolutely be the right way to do it.
Tell your boss that if you're not doing the authentication and filter, you're doing it wrong.
We are. He just doesn't like filters.
That's the only way to do authentication. You want to put like a is authorized check in every single endpoint, or do it once in a filter.
Ultimately, absolutely that's the right way to do it. Now, it gets a little strange because there's a lot of, like PHP, there's no concept of filters. I don't know about .NET, but I think there actually is kind of the concept of filters. But the Java application servers really kind of are ahead of the curve here. Because you've got not only the concept of filters and catching things on the request, you've also got request valves. Request valves actually make really great access control endpoints. So ultimately, yeah, you want to catch things as soon as you can. When you're introducing security, it's really, in my opinion, your best practice is to enforce the security at the earliest point possible. Right.
Have you noticed any problems with loads? I mean, ESAPI uses what their current user, which is a red local user. Have you noticed any problems when you do use it in a filter? Like if you're getting millions of hits and everything is going through that filter, have you noticed any problems with that?
So our application serves several million hits an hour. It's not by any means a small.com. And I have yet to see either the filter or the thread locals cause a problem. It's always one of the big concerns in Java with thread locals is thread locals are tied to a thread that's global to a thread, if you will. And in Tomcat applications, in Java application containers, everything uses thread pool. And so a thread basically is tied to a request for the duration of that request, and then it gets recycled and goes to another request. So if I throw sensitive information on a thread local, it's up to me as a developer to make sure that that gets cleared out before the response is committed. Otherwise, user A has his session information on a thread local, and then that thread gets recycled back into the thread pool, and then user B comes in, and all of a sudden user B is actually user A according to the system. So there's kind of a manual process that has to be run there, and that's kind of the great thing about how we do it with the filter, where in the request filter, so in the lifecycle of a request through Tomcat or any application server in Java, I can catch something before it gets to the meat of the request. So on its way in, I can catch it, say, do this on the request, throw this user on the thread local, and then it comes back through that filter as the very last thing that happens. So if it executes first, it also executes last. And that's when I can clean up that code and make sure that those thread locals are cleaned out.
So is it enough for that thread management just to initiate your current user in the filter and then make sure at the end of every servlet or at the end of every whatever you're processing to clear that user?
You want to throw it in and basically, and so you've got the concept of a try-finally block. So the thing about the thread locals is you want to make sure that no matter what happens in the duration of the request, I need to make sure that this code executes. I need to make sure that this thread local gets cleaned up.